Hi everyone. Today I'm going to present my paper named Reason Level Data Attribution for Text-to-Image Generative Models. First, let me give the definition of data attribution. This is when we try to measure the contribution of big training sample on the prediction of model during inference for the text-to-image generative models. A special property is that its prediction is images, so we can visually recognize the contribution of training components on the synthesized image. However, all existing attribution methods for text-to-image models just focus on measuring the contribution of training image on the generated image, but are not able to extract the contributed reason for a particular object. Our method is the first one for region-level data attribution and can work exactly for attribution of the objects. We propose a attribution reason detector, ARD, by extending architecture of counting method CountGD. Its input are P and Q, which are the text prompt input and the synthesized image of text-to-image model during the inference, and the region of interest are Q. It also takes a training image X as input to predict the attributed reason and its attribution score. To train our method, we assume that we know some positive training pairs here that RXI contributed the most to the region of interest RQI, and all target image XD from other pairs do not contribute to the generation of RQI. We divide the training process into two phases. The first one is the same as any standard detectors. And in the second phase, we only optimize the linear layers of the score head with using the focal loss that the score predicted for xj from negative pairs is equal to 0, and the score predicted for the target image xi is equal to 1. So how can we build the positive pairs that satisfy above assumption? First, we ask the GPT to categorize classes into groups, then create templates for each group. Then we use these templates to create the prompt as the input of the text-to-image model customized by the recursion. By using this way, we ensure that the generated object is contributed the most by the object in the training image. Finally, we construct the negative pairs by collecting target image from other positive pairs. Here is the quantitative results of ARD compared to both image level attribution methods and fine-tuned few short object detectors for reason attribution. We can see here ARD outperforms other method, while the image level attribution method cannot extract the most contributed reason in the training image. Image level attribution methods are usually distracted by the background. For example, here we show here the top one retrieved image by ABC, and it is distracted by the background of the pink tree, although this image does not have any bench. Finally, we depict some application where we need ARD. For example, the first one is when training image shows some missing detail. This makes the generated model produce strange details regardless of the input prompt. In this case, ARD helps to retrieve the training objects that cause this problem. We can use this training, we can replace the training image to fix the model behavior. Thank you for listening. Here is our QR code for the project.